Okay, here we go. Here we go. Now I just have to put a screen up so that you can see anything. Wouldn't that be a good idea? I think so. Make sure all my government secrets are not on the screen. Okay, I think all the government secrets are gone. If there are any left, then RIP USA. But that's already how it was. I mean, we're pretty much at RIP USA at this point anyway, so. All right, how's it going, everybody? I was going to start by fixing a compiler bug that someone reported, and if that goes well, which it may or may not, it could be a really gnarly bug, or it could be an easy bug. I don't know yet. And depending on how that goes, we could maybe do some game stuff after that. Right? Right. Okay. So this bug was, this is the program. It has to do with relative pointers. And this relative pointer is like not decoding. Um, and I'm going to change the program a little bit to put things on the stack, just to make them more sane. And this program crashes, and in fact, LLVM complains about it. Yeah. x64 backend doesn't complain about it, but it's still wrong and it crashes. Because it does this first print regular pointer, and now it's like, ugh, and dies. And this program, it says regular pointer, and then it does some other stuff, and then says relative pointer. So it's like crashing here. And so we just got to figure that out. Yeah, I'm in Texas right now. I went to the Dallas area and I didn't love it. So now I'm in Austin again, where I lived here in Austin for about 2 years, way in the past when I was a youngster. And uh, just checking it out again. In my early videos, I showed a method to specify which outside variables are usable in a code block. Did I drop it? If yes, why? I didn't drop it. That might still happen. It's just been very low priority. Um, like you could do that yourself in a meta program if you wanted to, so it doesn't have to be built into the compiler. Um, and it's not as important as the other things that I've been doing, right? Like there's a difference when you start out and you have initial ideas for something, right? Those can be interesting and good, but when you start doing it for real, what I've always found is that I start having much better ideas because I'm wrangling with the problem in reality as opposed to what I thought the problem might have been, before I started. And so, the design of the language that I'm at now, I think is super useful and really good. And, um, we may yet go to some of the ideas that were discussed in those original videos. I mean, most of those ideas have made their way in one way or another, but some of them haven't. And it's just because they weren't necessarily exactly the right set of ideas, right? Um, I can go meet all the cool streamers. Are there a lot of streamers in Austin? I thought all the streamers moved to Las Vegas and San Diego. Like, doesn't like Shroud live in San Diego and then a bunch of people moved there? Have I been able to find a good laptop? No. You really like the using idea. No, using is in the language. Using is fine. You want to write a stackful generator. I don't know what that is, but it doesn't sound good. Why did I move from San Francisco? I'm not moved out of San Francisco yet, but it's a shithole that I don't want to live in anymore. And the taxes are about to get crazy. They're about to pass a law where they can tax you for 10 years after you leave California if you go somewhere else. It's nuts. Because they're broke and they're in a downward spiral of bad management, and the state's just going to choke on itself. Who is my favorite painter? Let me think about that for a second. You thought I was talking about using, no, I was responding. There was sort of a lambda syntax. I think that initial question, there was sort of a lambda syntax where you could restrict what names you were allowed to access in a sub block, right? And you can make that at user level now. But um, it's probably faster if you put it in a compiler. But I'm not sure that that's worth it. We'll see. But it might be more versatile, or um, it just might be better at compiler level because there's things you could do with it. Yeah, I don't know. We'll see. Favorite painter? I used to really just generally be a fan of the pre-Raphaelites, broadly speaking. Um, I mean, aside from that, I like Monet. I like Cezanne. I like Sorolla often. Um, hmm, of the pre-Raphaelites, maybe Waterhouse is my favorite. I mean, Raphael's no slouch himself, but I like that kind of stuff. I'm really not into most of the stuff that they're showing in museums these days. I think I think the art curation world has made a grave mistake in terms of what they do. You like sculptors? Yeah, there's sculptors I really like. I mean, Rodin is amazing. Like, I really like Rodin, sculpture wise. There's a lot of good sculptors. Rudy's for great barbecue. Yeah, I haven't been to Rudy's yet, but I used to really like Rudy's back in the day. And it seems like they've opened a lot more Rudy's. Like, there used to just be two, but like I drove past one like in Round Rock or whatever coming down here. So, yeah. Neuralink presentation. I'm glad they're making progress. It's a long way from a finished product, but um, it's good. It's good that we're actually working on things. It's really scary that most of the forward-thinking technology that's actual technology being developed today is all because of Elon Musk. Like, why don't we have like 10 people doing stuff like that, right? Or I mean, there's a lot of people involved in those companies, but like, what what's going on, right? Why are we so bad at this? Seems to you that some game mechanics in relatively cute games have really creepy connotations. I think there's value in making a game that appears cute, makes the player realize the creepiness of its mechanics. I don't really value creepiness that much. I mean, it can be nice. It can be, okay, it could be an interesting thing to do sometimes. The problem is it's very easy to do creepiness that actually isn't very deep and so isn't that interesting. And it's one of those things, in the same way that like most most science fiction writers started doing cyberpunk dystopian future stuff for a long time. Like a lot of indie people do like creepy whatever. And it's just too much. It's like if you don't have other ideas in your head, you're just not doing anything that valuable. If it like if everybody's already getting that from other places, why do you need to do it too? You know what I mean? You know what I mean? America taxes its citizens internationally, even if they don't set foot in the US. That is true. However, there are other nations that have tax treaties with the US. You could avoid being double taxed if you live in those nations. But also, I don't know anywhere other country that I would really move to except maybe Singapore, but that would be an endeavor even to look into that. Um, it's not like I'm gearing to leave the US, but yeah, that's a pretty weird law, and I'm not a fan of it. I've been to any museums in Moscow. Yeah, there's like a space museum in Vedonka, and I went there. It's like not the biggest, best space museum, but it was kind of interesting. And then we went to an art museum when I was there. I forget which museum. But it was a weird time because it was during, is it one night or one week when like all the museums are free and everybody gets in giant lines to try to get in? Like that's when I was there. So it was a little bit of an unfortunate time because we wanted to go to multiple museums, but it was just banana nutballs trying to stand in those lines. Neuralink demo has you worried about quite a few aspects of the technology. Yeah, I mean, I can see that. Like, I'm not a neuro person, so I don't have specific worries, but I sort of understand. But at the same time, like, it's just a stepping stone to somewhere better, right? Like going from, like, if you remember the Neuralink demo that happened a year ago with like the really, like they one of the things they showed was like the current technology, right? Going from that to what they demoed yesterday is huge, right? Even for just like labs that are doing this kind of experimentation. I actually don't know. I didn't see the whole thing, so I don't know if they answered the question of like if they're going to provide any of these to current labs at all. Um, but like just even that change from going to like this giant ass thing to like the little watch battery size thing is huge, right? How they're going to get around electrode degradation is beyond you. Yeah, well, here's the thing. Maybe they're just saying, hey, we'll figure it out. Like, we just don't believe enough people have thought that hard about it, right? Or maybe they have some ideas, but if they have some ideas, those are their primary trade secrets, right? I wouldn't be talking about that stuff if I were them. Would I hire a programmer who is absolute beginner in graphics field and has a strong passion for it? Depends on what they have to show. Like if you have a strong passion for graphics, then even in like 3 weeks or a month, you probably should have some demos, right? Otherwise, I question the strong passion for graphics. You know, and so it just depends what that looks like. A lot of the time, like it's very smart to hire for personalities. Like you want to hire people who are self-driven, who are smart, who can tackle problems, and who can do hard things, right? And if you hire those people when they're beginners, right, that's a good way to win or to get ahead of other companies because other companies might want to wait and see the pedigree and see like what who else have you worked for and what experience you have. But if you get those people early, you can get them before other people get them, and that's very good because it's hard to get really good people, right? Um, so hiring beginners can actually be very good as long as you have a way to train them up. Um, but most beginners are total flakes, right? And so It's not like you just hire beginners, right? It's hard. It's hard to hire the right people. Am I artistically satisfied as a game developer? Oh, totally, except that I don't get to do as much game design as I would like because I'm doing all this other programming stuff and doing non-programming answering Twitch chat questions for some reason. Do I think the indie bubble has bursted? Oh yeah, like long ago. Like back when we were saying there was an indie apocalypse and other people were denying that there was an indie apocalypse, that's when the indie apocalypse happened. Now we're in the aftermath of that. Pedigree is dog food. Do I have any plans for asynchronous programming? Yeah, make threads. What indie bubble? So from about 2009 to 2013, if you made a pretty good indie game, it was very easy to make money off it because the market wasn't flooded yet. And so it was very easy to invest in indie games because we could have confidence that as long as we could make sure they finished the game, we would get our investment back, right? Um, and if you wanted to go off on your own to do stuff, it was a good time to do that, right? Maybe even till 2014 a little bit, but ever since about 2014 it got hard. What are my thoughts on that aftermath? Who will survive it? What do you mean? I mean, we're in it right now, so you see exactly what it's like. Like a lot of people can't really hack it as indie developers. Other people can. Um, it just is what it is now, right? Most will get wiped out. That is correct. All right, let's what caused the indie apocalypse? It's just that it became easier to make games. So a lot more people did. And the market did not grow in the same proportion as the number of developers grew, right? And so there you go. Why am I at a hotel? Because I'm looking for a place to live in Austin, maybe, except I'm not actually looking that hard right now. It's officially an art now, and a lot of developers are starving artists. Yeah, right? Basically. Have I always programmed games? Yeah, since I was about 10 years old, except they weren't really real games till after I got out of college. Have I ever made software for like industrial applications? I did a little bit for like less than a year after college, but not really. Got to drive from California? No. Weather is brutal hot in Austin right now. Yep. I mean, it's good in the morning and it's tolerable in the evening. Um, but during the day, I'm indoor right now. Let's put it that way. This is why I am in the hotel room. Have I read a book called P? No. How was the flight? It was good. How do you organize project planning? Org mode? No. We just do what we need to do. Okay. So, I set up a breakpoint. I did a little bit before the stream, um, determined that well, I put in this assert was going off in the debug build, right? This is the one that actually, when we're here, we try to run this and we get this assertion that it's trying to dereference a pointer, right? And it's not, the thing passed to it is not actually a pointer type. So I don't know anything else about this problem besides that, so I thought I would break here. This line number on here tells us where this got generated. So we can go there. Um, okay, where are we and what is happening? This is emit struct dereference. All right. Um, let's just see. This is line 31 of the program. Yeah, so it's here. This assert is actually crashing. So we're trying to do like t.rel2.val either here or there, right? Probably this one, right? So t.rel2 is giving us something, and we're trying to dereference that. And it looks like we're not doing something good there. So why? Why? Am I using Emacs 27? I have no idea. MetaX version 26.1. I mean, Emacs just gets worse every version, so I'm not sure why I would go to 27 at this point. Okay. So we have a dereference, and we determined that the instruction generating this was, wait, we lost the line number, oops. Lost the line number, it was 2374. Okay, so this here generates a pseudocode like bytecode dereference, and the struct register, I guess, is not a struct somehow, right? So maybe, let's see where that, does that just get passed in? Yes. So whoever is calling this is maybe calling it with something that isn't correctly decoded, like it's still an integer and it hasn't been turned into a pointer yet. Let's see what happens. So this serial should state, oh, come on, dude, the bugs in this program drive me nuts. Oh my God. Okay. There's something special about the top line in Visual Studio, and like it doesn't respond to events correctly. Only the top line. The rest of the lines are different. Okay. So we want to go break in emit struct dereference. When we generate this instruction, that will have this same serial number that I just copied, right? And when we do that, then we can see the call stack when this was generated, right? So we're going to go here. We're going to go conditions. There. Close. Hopefully that works. Nope. Why not? Are we running? We are running no jobs. We could also do it by line number, but the serial number Wait, why is it different? Let's do it again. That was 2567. 25. Did we incorrectly copy the number? I don't know. Let's try 2567. I'm glad that I don't know. Imagine if you didn't have good short-term memory or were dyslexic about numbers. It's so much harder to debug. Okay, so we are hopefully in the right place. Line 31, is that what we were saying before? Let's see. Yeah. Okay, so this is actually, we're generating for this dereference. Um, and we can look up the call stack. So we said emit expression left. I don't know that that would decode the relative pointer, honestly. We might just be forgetting that. Let's look at how that's supposed to work. It's been a long time since I've looked at this. Is there like a decode? Emit load relative pointer. Okay, so maybe we're supposed to emit a cast here and we're not, maybe, right? We're supposed to cast from the relative pointer to, this would be an error earlier in the pipeline, right? Like if we're supposed to cast from relative pointer to full size pointer when we do a dereference, which would make sense, and we are not currently doing that, that would be a problem. Um, yeah, that's emit pointer cast. The emit conversion to full size string, that's only for strings. That doesn't do anything. Um, emit cast again. That's for array elements. That's it. So I think we're supposed to. Put a cast in. Ensure pointer is not relative. So we make a cast here on ensure pointer is not relative. Okay, let's verify, before I go into this, let's verify that that didn't happen, right? So we have this binary operator, right? It's a dereference, and then we've got another dereference probably. Or wait, no. Okay. So this is a dot. So if it's a dot, we just recurse right down into here. Um, how's my camera? Is it covering anything important? It's hard to tell because I can't see both of these things at the same time. So this is the point where the camera goes to. That's probably fine. Okay, so this is just says emit the left. So let's just check what's on the left, right? We know what's on the left. It's riots and burning things down in Portland still, but it is what it is. Um, right, so that is a binary operator that's going to yield that dereference of that pointer field. Um, that pointer field, like I said, yeah, I think we need to call this. So ideally, what we would have done is, when we did type inference for this thing on the left, we see, oh, it's a dereference. It does something. It gives us back a relative pointer, and then we're going to use that relative pointer. We need to make sure it's not relative to use to be a dereference, right? And yeah. All right, so let's see who calls this. Ensure pointer is not relative. Uh, okay, for the case of pointer math, we do this. For the case of yeah, see, this seems like it's happening in kind of a piecemeal way, which is not great. Um, so that's unary dot. That's a different thing. Taking the address of things. I think we need to do this. Right, so when we do this, ensure pointer is not relative. Do we use this create new pointer type? I don't think we do. Oh, yeah, we do. Okay. So we make an explicit cast and we return that. That's fine. I should be able to do this. Let's just say, we're just going to put that there to mark that that's our new thing that we're doing, because there are other calls to this that were old. We'll take those out later. Why is there no, oh, this is unary, right. So infer types for binary, array subscript, okay. If it's not constant, I think we need this here. Okay, we need to make sure that the thing we are dereferencing gets decoded if a relative pointer exclamation point. Okay. We'll see what those things do. Hey, we didn't get the LLVM error anymore. Um, we did get an assertion failed, but that might be because the program is slightly wrong, or it might be because we're doing something wrong. But let's look at that. Let's also run it in x64. Oof, x64 looks like it's crashing. That's not good. Okay, let's see. Um, so this is line 41. So we're asserting that it's 1,000. Okay, well, we didn't crash at either of these places, which is good. Um, so t dot foo, let's take a look at, okay, t dot foo, that's just an integer. T is a thing, t dot foo is this integer. T dot rel is supposed to be the address of t dot foo, right? And so when we print, are we printing t here? Yeah, we're printing t. And when we print this, t dot foo is here. Rel is r minus 16, and so that points 16 bytes earlier, so we can make sure that's the right amount. This is rel, this is 8 bytes, that's 8 bytes. So yes, r minus 16 points to the beginning of foo, so that is correct inside the struct. Are we using it correctly? I don't know. So then we say regular pointer foo is now 50 after saying t dot pointer. That's a regular pointer. Okay. This whole inner thing, we're not really having a problem with that right now, so we're going to skip that. And then where, so maybe we're just putting this 1,000 in the wrong place. I don't know. Let's just say, let's do this. We're going to do that. So yeah, we don't seem to have done that. Okay, so let's just do the following. Print address of t.foo is equal to whatever, right? And then print um, we're just going to manually cast that and just make sure that they're the same address. They are. All right. So So we're going to say t.foo is whatever. We're going to say if I manually cast that to be non-relative, because maybe we're missing that cast even though I thought I just put it in, we might be missing this one. So although that would crash it. So maybe, I don't know, we need to look. Okay, so if I manually cast it, I'm gonna make it 1, 1, 1, 1. And then in the after, right? I mean, that worked, okay? So this is after 1, and then we're going to do this. We're not even going to cast it, right? Because we should just be able to do that. And then after 2, should be 2, 2, 2, 2, but probably won't. Whoops, probably won't be. No. So when we generate this, this is incorrect for some reason. Um, for some reason, so that's what we have to look like. And then, so once all of this, it's really, I guess we didn't have enough test coverage on relative pointers because these are some very basic operations that are happening. And they just broke over time. This happens sometimes if you don't test for things. Like you'll have some functionality that works and then it kind of breaks. And we don't really use relative pointers much yet in our code. My plan was to use them a lot eventually, but they're still very experimental. And so one of the beta testers was using them and ran into these problems. And I'm surprised that we didn't have the test coverage for this. I don't know what happened there because I certainly had demos that did this. So either those demos got deleted and not turned into test code, or I don't even, maybe they're doing something very specific and this is slightly different and didn't generate the problems. I don't know. I don't know. The relative pointer is the syntax making it assign to the pointer the relative pointer points to. It's making it assign to the value that the relative pointer points to. A relative pointer is in theory just a pointer. It's just smaller, right? It's a baby pointer. It's a baby pointer. Okay. Okay. So, I mean, we could just look at this one. This is the first one that happens, right? So line 34, we could go, not derf, not derf. No, it's not that. It's here. Is this infer unary? Yes. So we can go here and say conditions unary L0 is 34. Is that right? Yeah. All right. See what happens. Okay. It's in our file, so we didn't inadvertently pick up a different one. You got to check for that because sometimes that happens when you go by file name. So it is this one. Let's see what happens. We error if it's not a pointer, but it is. And now we do ensure pointer is not relative. What is sub though? I don't know if we necessarily want sub. Sub, oh geez, yeah, okay. No, this is me being stupid. So the deal is this adds an implicit cast on the ding dangler, right? Is it called sub expression? See, we copied that into a local variable, so I'm putting this implicit cast on the local variable, which obviously then nobody's going to know about that later. That's just not a thing. Okay, so, okay, this is good. It's doing the right thing. Now later we're complaining it's not 1000, but it shouldn't be 1000 because we mucked around here. So now if we remove our new test code here, then maybe we shouldn't assert anymore. All right. X64 should not be any different because these were front-end changes. All right. Fixed. I think the next step is to make this into a little more of a test and have some test coverage. I am a madman. You can clearly see by this stream. I don't understand. What is so madman about this stream? Yeah, if we knew that Witness would sell as many copies as it did, it probably would have been $30 instead of $40. It's just, I was protecting against it being too niche of a game. Like if you think that only the people who are super, super, super into this tweaky thing are going to buy it, and that they value it more than a general public might, then you go for that a little bit higher price point, right? But if we knew that it was going to sell more copies than Braid, which it has, we would have made it cheaper, probably. And it probably would have made a little more money because it was cheaper, or a lot more money, maybe. Yeah, it's you know you can't predict the future, and you don't know how well things are going to sell. So I already had a following. That's true, but Witness was a really weird game, and I was not allowing us to PR or market the secret of the game, which is, like if you wanted to tell people why it's an interesting game and not just you drawing weird lines on the screen, then you spoiler all the cool parts of the game that I wanted to save for people to discover by themselves, right? So all of those things. Okay, well this is good because we fixed a bug. That is good. I sort of feel like there should be relative pointer test already. Like, why is there no file in here called relative pointers? There certainly was a relative pointer demo, and the original thing was that stuff was supposed to get translated into tests. Actually, I originally just wanted the demos to be the tests, but there was a miscommunication there and the demos got mangled and whatever. But yeah, so apparently we just don't have a relative pointer test, or maybe it's buried in some of these other tests, but it doesn't test the whole thing. So we're going to add one. Relative pointers. And we're going to start by just copying this tingtangler, right? But let's make it a better test. In fact, we could also maybe we could sort of write the how-to because we don't have a relative pointer how-to. That would be better because those also get run as a test. Although this, let's not worry about it yet. One thing at a time. So in general, I mean, people are arguing about basic price stuff, right? In general, there's a curve, right? The higher it's obvious, it starts with an obvious fact, right? The higher that you price something, the fewer people will buy it, either because they can't afford it or they don't think it's worth that much money or whatever, right? Um, or or the lower you price something, the more people will buy it because they think it's a better value, it's cheaper. Why not buy it, right? It's so cheap. Or they heard about it from word of mouth, and you get more word of mouth when more people buy it, right? So there's sort of a feedback loop. So all things being equal, you kind of want something to be priced lower than higher usually, unless the perception that it's a luxury good is supposed to be part of why you want it, right? Which is like, gold watch territory or something. But um, anyway, the thing is that's not an exactly linear relationship, right? If it were exactly linear, like if if you could sell something for $60, right, and get 100 people to buy it, or sell it for $30 and get 200 people to buy it, that's exactly the same mostly. I mean, in software, it doesn't cost you anything to make twice as many. So you might as well just sell it for $30 and have more people enjoy it, but make the same amount of money, right? Although, except no, because you have a higher support cost. So you'd actually, if it were exactly the same, you'd actually rather have the more expensive one. Um, Especially if some of the $30 people buying it are Linux whiners who complain that it doesn't work on wine or whatever. Um, so the thing is, it's not linear, right? It's actually often way super linear. So, if you sell something for 30, way more than two times as many people will buy it. If you drop it to 15, more than that will buy it. But at some point, you also get diminishing returns there. Like if it's $1, maybe not that many more people buy it than if it's $10. And so you end up losing a lot of money at that point, right? So it's like enough more people have to buy it to make up for the price drop, obviously, right? And so if you graph that, you end up with some kind of weird curve, and you kind of want to just guess the right point on the curve. And it's hard to make the right decision, honestly, because it's complicated and there are many factors. You're working on wine right now? Okay, well, please make everything work perfectly on wine. Thank you. You're working on drinking wine? I could do that. We have hotel mini bar wine here. Okay, well, let's do self-referential struct pointers, right? I mean, because this is a test, it doesn't really have to be pretty. I actually shouldn't, I should rewrite it, honestly. This is code that somebody else sent us as a test case, and we don't really have copyright rights to it, and we could ask for that, or he probably wouldn't care, but I should just write something from scratch. Let's do, we want struct pointers, um, we want um, relative strings, we want relative arrays, and I guess we use a pool for this because we want to allocate things and know that they're near each other. $20 glass of wine. Okay, guys, let's have a competition. I just submitted. I had laundry done by the hotel today. Um, it's 5 days worth of clothing, except that I wore the same shorts for 5 days, so there weren't really any pants in there because it's so dang hot. So it's actually 6 shirts, one pair of shorts, and then socks and whatever else. So let's guess, how much did it cost to do this laundry? And the additional information is that there was a charge for express service because if you don't deliver the laundry by 8:30 in the morning, then you have to get it back the next day. So my option to get it back today was to pay an express service fee. So how much did it cost me to do about 5 days of laundry in the Fairmont Hotel with express service? People are guessing. Okay, okay. Most of you guys have no idea how much hotels rip you off for laundry. Oh my God. And it's not even just the Fairmont, like almost every hotel just rips you off badly for laundry. Okay. The answer is, let's see if we can get this on the camera. So the moral of the story is don't do laundry at hotels. I actually, when I was in England last year, it cost like 500 and something dollars. So this is kind of cheap. That's a whole pizza. Yeah. Okay, now, so of that 234, $50 of it was the express service charge. So it would have only been 184 if I was willing to get it back tomorrow. So today it's just I wanted to wear those shorts tomorrow and it would have come back tomorrow afternoon. Just go to a laundromat. Yeah, but I wanted to be here streaming and programming and not at a laundromat. I don't even know where there's a laundromat. I would have to figure it out. I would have to get COVID from the other people in the laundromat. Artisanal folding labor. Yeah, it's exactly what it is. Buy new clothes. Yeah, I could have bought some new clothing for less than it costs them to wash it, honestly. few bucks in Indonesia. Yeah, Thailand too, man. If you're staying at like a little guest place in Thailand, they'll do your laundry for not that much money. Now, all that said, hey, at least I'm supporting the economy, unlike the mayor of Portland. All right, so we're going to have some relative strings. This is going to be weird because, well, let's start doing some pool stuff. Pool is a pool. I think we have an ensure space, right? Oh, what is it called? Oh, we just allocate, right? Duh. Duh. Okay. Let's just say memory is get from the pool, I don't know, 100 bytes, whatever. Um, we're going to cast memory or cast memory to a pointer to a 16-bit relative string of memory. So we're packing this string in there, right? Maybe I shouldn't put these all in different functions. Maybe it should all be in the same. So we're going to make a relative string. We're going to say um, right? So s.count is hs.count. Um, let's say memory plus equals size of s, right? S.data is memory, and memcopy memory hs.data hs.count, right? And then memory plus equals hs.count. So this is copy the value of hs into the buffer, right? So these strings, they're not C-style strings. They're not just a pointer. They're like a pointer plus a length count, right? And so we're setting that length, and then we're copying some memory in, and then we're setting the memory, right? And then we're going to say, so we've packed that into a pool. So let's see what happens. Whoops. Extra brace. Why? Why is there an extra brace? What did I ever do to you? Prematurely Ending the file. Oh, it's this stuff down here that I put off the bottom. All right, duh. All right, loss of information, right? Because this is a 64-bit length and this is a 16-bit length, so we're casting it down. Oh yeah. I keep wanting to do C-style type or size of. It's so tempting to make that. Okay. No program entry point. Okay, so this entire string is packed into 8 bytes because it is 2. Wait, why is it 8? Should be 4. A string with 16-bit values should be 32 bits. Why is it not? Why is it not 32 bits? What is wrong? What if I do this? What if it's S32? Same size. What if it's S8? Then it's 8 bytes? Okay, we need to fix that. That is an error. I bet when we size things, we're saying if it's a string, it's 8 bytes, and we're not looking at the relative pointer type for some reason. It's a pointer to a relative string. Oh, duh. Okay, sorry, I can't read chat. It's on a tiny phone. No, you are correct, everybody who says it's okay. Okay, so this is a little bit of a redundant thing, but we're going to go. Okay, so we're going to say size of the string type is this, and size of type. All right. And right now it's actually should be 2. There we go. It's not broken. I'm just broken. Okay, so now let's make it 4. Right. It's a little weird. There's always this dichotomy where the types are in bits. Like maybe we'll just massively rename everything and just have all the types be in bytes instead of bits. You know what I mean? Because like thinking about these two things all the time is a little bit weird, except sometimes you do want to think about bits. I don't know. Okay, great. We still have a lot of memory here. We'll call this various. So we're going to do a relative array. We're going to say Um, A is cast to a pointer to resizable array of, I don't want strings of float. Let's do float, right? Oh, let's make this one S8, actually, because I want to play around with the different sizes. S16, because if this array is very long, you're not going to be able to fit it all in 8 bytes, whereas with this one, we know that the string data is packed for 8 bits. With this one, we know that the string data is packed right behind the string like header, so it's always going to be in range, right? Okay, so here, it's a pointer to an array with S16s of float of memory, right? Of A, right? And then not memory. And then let's just say n is 10, right? So a dot count is n. A dot data is memory. Floats is cast to memory plus equals a n times size of float. All right. So what we're doing here is just scary direct memory manipulation to pack a bunch of stuff into a buffer, right? And it's the fact that it's packed into the same buffer that you know that you can use relative pointers in the first place, right? If you're going to point from the stack to the heap or the heap to the stack or whatever, relative pointers will not do that for you because those things could be very far from each other. And the pointer, well, a relative 64-bit pointer probably would. But apart from that, no. All right, so here we're going to have floats, and we're going to say for 1 to n floats, it is cast float it times it. So we're just squaring them, which is a common thing that we do. And then print a is whatever. I don't think our print function prints arrays, though. It'll just print the type of it, because arrays could be like trillions of elements long, and we don't like have a heuristic for printing it if it's short. Yeah, oh, it just prints the, oh, because it's a pointer. All right. So count is whatever, the data is whatever. It's interesting that we don't print the type being relative here. That's a little weird. Maybe we should fix that today, right? Okay, so so that should be a 4-byte array. Whoops. Size of type of A is 4, but then I asserted what? Oh, we forgot the ting tangler. Somehow I knew I did that before even looking. All right. So for A, print A of whatever equals whatever, it index and it, right? Argument 4 is not an array. Oh, guys, I'm just a goofball. All right, so um, there we go. It worked. So that's all good. That is all good. How we doing in the chat? Well, you make the language runtime allocate the heap at a very high virtual address in order to explicitly break relative pointers between stack and heap. The thing is, like, you can sort of decide that on a per operating system basis, but you may not have a choice on a particular operating system about where the heap goes, right? Like, I don't even know. So you always increment memory by 8, not by the size of the relative pointer. What? Oh, right. You know what we should do, just to make this more readable? Let's do this following. So we're just going to say this and say whatever the string type is, right? Let's make sure that parses. Oh no. Guys, we have a compiler bug. A bug ski. Really? That's so weird. How about that? Okay. We have to fix this separately. That's just an oversight, probably. Simple oversight. All right. So for now, we're just going to pretend that didn't happen so we don't derail ourselves. Okay, so this works. So instead of size of type of, we could do this, right? And the reason we do that is we could also do the array type, right? Array type is type tilde 16 floats and casting a pointer to an array type. That might also just make it more readable, right? Like, because when you see all this stuff together, you're like, what is that? And here it's like, okay, it's a pointer to the array type, whatever, right? And then we do that. And it just, because we don't have to remember to do the dereference all the time. That is what you meant, right? It also lets people know that the relativeness applies to the array or string type rather than the pointer. Yeah, I mean, that is unambiguous because if it applied to the pointer, it would be after the pointer, right? Like you could have the following. You could say T is pointer relative S32, array relative S8 of float 64, right? Like that is totally a thing that you could do as well. So if you're used to the language, that it's not really a question. But yeah, it is just, you know, maybe slightly nicer to do this. Okay. Oops. Okay, that's great. Now, okay, because these are relative pointers, we can do the following magic. Let's just say memory size is 1,000, right? So we got that memory from the pool, right? Now we're going to say buff is memory size of U8, right? And we're going to mem copy buff.data memory size, all right? And then we're going to say, because the pointers in there are relative, all I needed to do was mem copy this, and then I have totally valid data. Now the thing is, okay, so okay, T is cast a pointer to string type of buff.data, and then we just, okay, here's what we're going to do. We're going to say orig memory is memory, because like this array of floats starts somewhere in the middle. So we're going to say array offset is memory minus orig memory, right? It's just how where in there is the array, right? So T, or let's, yeah, and then let's call it S copy, and then A copy is cast pointer to array type of buff.data plus, they call it array offset, yeah. And then I'm going to say print S copy is whatever, and I'm going to say for a copy print right. Well, that didn't work. What did I mess up, people? Offset is smaller in size. I don't know what that means. This shouldn't matter because we're messing up on the string, but let's see what it is. It's interesting that it ended up 16 bytes, but okay, so S copy didn't work. Why? Ha ha, you are correct. We copied from the wrong, this memory has been modified, right? So it should be a ridge memory. That is exactly correct. We copied garbage memory instead of actual non-garbage memory. There we go. So we set up all these data structures, we packed them, and we just copied the buffer. And because all the pointers inside are relative, the fact that we copied the buffer just meant that we could use the data structures again without having to fix up any pointers or anything, right? Which is nice. You could put binary trees in there and just use them as binary trees and it would just work, right? That's all. That's all we were trying to do. That person is not fired. Correct. That person is not fired. Congratulations, you're not fired. I guess I am fired, but you are not fired. Okay. Did I add I did add this to source control. That's probably a good enough test for now. Let's actually make sure. Oh, you know what? Didn't we add some no check-ins? I know I added at least one. Yeah, these, we were marking these and then there. So this was just our debug hook, so we can get rid of that. And then this just belongs there. So we're going to run debug on all the tests and on the game and make sure that we didn't break anything, which we really shouldn't have, but we'll find out. We're running the super debugly build on here. All right, we're going to be editing this level a little bit, so let's clean up all this stuff. That was just a test I was doing. Deleting things is kind of slow. Oh, probably because it removes the, I don't know. I don't know why deleting things is that slow. Anyway, so the game runs and uh-oh. Oh, okay, this does not have anything to do with what we were doing. I'll show you what this is. So somebody sent me an email and said, hey, see this toString function? I didn't test after I made this change, but oh, it was this one. This toString used to be this. I used to just say, oh, take a buffer that's an array of U8 or an array view of U8 and just, this is just an overload that calls toString on the data. And it's like, okay, wait a minute. That assumes this is zero terminated, which is kind of weird. It should act just like this one, right? And use the count. So I was like, okay, we'll use the count. And apparently that breaks one of the tests in here. So great. Why? ToString of S1. So this is zero terminated. Um, so the deal is just that one of them has a zero in the, wait, what? So right, this plus a 0 is 15 characters. Okay. Is that adding a 0 for some reason? No. I don't like this is I don't like this nested thing for no reason anyway, but really all that should be happening is um, like none of this should matter, honestly. Like why are we this is so annoying, but it's because we didn't have macros at the time and they wanted to print these things. I wouldn't have written spam code like this. It's not good. Like these messages just shouldn't be here. It should just be the assert. All right. But I'm not going to rat hole on that right now. So what we're saying is that toString of S1 is not equal for some reason. It's not clear to me why. What what would be going on there? Oh, because this size includes the 0. Um, this like is not a valid test. This would be a valid test, right? That's all. Okay. Yeah, that's all. It's so all that's happening is this is like a statically sized array, so it includes the number for the 0. This call to toString downcasts this to an array view. All right. So it's an array view and the count is going to be equal to size, and that size includes the 0. And so, yeah, you shouldn't make assumptions about that. That should just have the 0 in there. So it is what it is. Replace with macros. Yeah, I mean, I want to do that. Like it's on the list to make assert be a macro. Um, because you want to, you want to be able to look. We could actually maybe experiment with that. It's just I kind of wanted to do some game stuff instead. But assert in C is a macro, and that's how it's able. It like stringifies the argument, and that's how it can print assert messages. We hadn't been able to do that earlier in language development, but now, of course, we can. If you've seen some of the recent strings, like we have full Lisp macro power, and once you have like that kind of macro power, obviously you can do stuff like generate the string from the assertion or whatever, right? It's just we didn't have that capability back here. And so the only thing is assert is used all over the place. So I kind of want to make sure it's clean and that there's just, if we do something like add a compile time execution for every assert, that's suddenly a buttload of compile time executions, which affects your compile time in a negative way. So I would want to do it without that, for example, um, which I'm not sure there's a good way to. So it's like, hmm. Do string literals include the null terminator in the length calculation? They do not. But the deal is, this isn't a string literal, right? This is like an array. So they're starting out doing something funny, and that's why this needs to have the 0. That escape sequence was wrong. It should be backslash. Oh, yeah, right here. Okay. Yeah, it's a good point. Dude, I hate all this. I won't, backslashing in strings is banana cakes. Okay. Well, our pointer math test had some relative string stuff in it that is now asserting. That might just be that it used to be wrong and is now right, or maybe we broke something. Let's see. Let's see if we broke something. Okay, line 107. Assert A is equal to B. Okay. Like, yeah, okay. So this is pointing to a buffer that's also on the stack. So for some reason, something is going wrong here. A is hello, B is nothing. That's weird. Buffer.data is not, that's not right. What? What? Squeeze me? Baking powder? So this one is a weird one because it's actually encoding a null pointer, but like what? That is an array on the, that should not be null, bro. That's just not, that is not an, null is not an option here. No one ever writes to buffer before using it, doesn't matter. In fact, they do. It's here. This is the place that fills in the buffer, right? Because this gets set to the data. This is exactly like a C array. It's just 100 bytes. So this sets you to the 100 bytes, and then this copies into it. I don't know why this memcopy doesn't like crash if this is null. I kind of don't necessarily, like, what? All right, we're gonna take this to the side here. Ay, ay, ay. Doing some very basic things. All right, and then we're gonna go sub-0. Okay, so what's happening is when we're printing buffer.data, for some reason that's going haywire and it's dereferencing it, which is not what should happen. We should actually have a subscript. Is source dest wrong way around? No, we match C for the arguments to memcopy. This is an old test, so it worked before, yes. I assume that this is our ensure pointer is not relative is doing something weird here. Like what I assume, and you know what they say about assuming, right? Remember how we had these no check-ins? Okay, it's not this one. I think it's probably this one. So if we temporarily comment this out, oh, maybe not, actually. No. Hmm. Yeah. That's still wrong too. This is very strange. Did we change something else? Oh, that's a different bug fix that I didn't check in. Whoops. These were just some comments that I added. No real code change there. Oh, that's another bug that I checked. I fixed other things and forgot to check them in before the stream. Whoopsie. And then that's this thinger that we're doing. And this shouldn't matter. Okay. I mean, maybe I wasn't correctly testing in some way before. Like I'm at this point, I don't really know what is going on with this. What if I assign it to another declaration? Okay. That all looks correct to me. right? That all looks fine. So why are we freaking out here and printing 7? Like, this is weird because there's no relative point or anything happening here. This is just a buffer. Converting the pointer into a string. It's a pointer to U8 after all. Well, that shouldn't happen here. It should get converted to any. But I guess you never know. I guess you never know. Okay, well, that's weird that that cast doesn't work. It probably should. Okay, this is the problem right here. When we convert this to any, we are doing the wrong thing. Which I don't know how that happened. Wait, what? It says it's a pointer. Oh, but the value, right. It's a pointer. Is this called data pointer? I don't know. Value pointer. I think that's a pointer to void, so I can't do that. Maybe not. It's Fifi is the value of the pointer. This is weird. Yeah. I'm just going to do that. Cast in the pointer. Okay. Yeah, this is incorrect. So this value pointer is supposed to point to something that has the value inside. So when we cast this thing to any, I am goofing. I am goofing. I don't know how long that's been broken. It doesn't seem to depend on the stuff we did on stream. So, but I was just running tests last night and they passed. So I don't understand. I don't understand. But maybe I did something late last night that like broke this and didn't notice. If you also set buffer sub 1 equals 9, what does it print? Well, I assume that it'll be a larger value, right? Because it's just taking the 8 bytes, which are mostly 0. So if I do this, it'll be like 9 times 256 plus 7, right? Yeah. Or no, 9 times, why is it only 907? I don't understand why it's only 907. Hmm. What? That's really weird. I don't want to rat hole on this because it's probably something dumb. 107, why is that 100? Wait, what? Why are we acting like this is decimal? What is even happening here, guys? Can someone explain to me what the hell is happening? Why are these hundreds? Oh, this is hex. This is a hex value. Okay, never mind. We're just not drawing the 0x. Yeah, yeah. Okay, we're fine. This is exactly what we expect then. It's all good. All right, clearly we need some brain power. And the way to get brain power is jalapeno lime late July snacks and some water. So we're going to do that, and then we're going to continue investigating. Chocolate. I was eating a bit of chocolate, and it's not that good, and it's not helping. So we're we're ratcheting it up to the chips. Chocolate is not that good for brain power. I don't know. It's just I don't like this chocolate. So if I don't like it, it's not going to be good for brain power. Come on. Okay, before we keep going, let's not forget to take credit for, um, we haven't shipped a beta in a while, so I've been doing other things, but um, fixed a crash, uh, fixed a crash um, involving relative pointers not being correctly decoded in some cases. Great, great. Best snack in the world? I don't even know. I need chocolate peppermint crunch, probably. It's just I'm in Texas and I don't know where to get it. I should drive to HEB and see if they have it, but I don't want to get my car out of the valet. Maybe I should. All right. People are telling me it's mandatory for me to have chocolate, so I guess that's what I'm doing. Well, I just do not want to fund idiots. That is correct. That is the best summary. Fleeing the wealth tax? Yeah, sort of. I'm more like fleeing the oppressive will tax you after you leave tax. Um, the wealth tax would probably not apply to me right now because I don't have that much in the bank. It depends though, because like you could claim that if I sold the video game company and all the IP, that that could generate enough money to make the wealth tax apply and that therefore it applies, like because that's the valuation or whatever. I would never sell the Braid and Witness IP like that, but you could make that argument, right? And so it gets weird. Is it even legal? If they try to pass that law, people are going to sue them immediately under the grounds that it's unconstitutional. But I don't know how that's going to go. Have I bought a house yet? No. I was going to just airdrop into Dallas and buy a house, but like it really just doesn't seem like a very enjoyable place to live up there. So I don't know. I don't know what to do about that. Political situation in San Francisco is unbelievable. It is pretty bad, but it does seem to be better than the political situation in Portland or Seattle. So I will count my blessings there. You're selling your house in Austin? Yeah, I don't know if I want to buy a house here. Um, you hear Austin is pretty nice. Yeah, the problem with Austin right now is that unfortunately, like many other cities in the US, it is becoming more and more, it has like a homeless problem with a bunch of methed out homeless dudes that make being downtown like unsanitary and a little bit dangerous, and just generally unpleasant. And like those homeless dudes should be having better lives than they do, right? And like it pains me to see Austin start going the way of San Francisco, but that's kind of what's happening. Um, Although actually, Dallas sort of was too. It's just with Dallas, it's a bigger city with a smaller problem. But I didn't want to be around downtown Dallas either. Like, I think the deal is meth just got a lot more nasty over the past 10 years. Like, I was reading a report that someone sent me that in San Francisco in 2019, in incidents under which homeless people were arrested for some reason, which probably has to be kind of extreme incidents. They tested positive for meth over 50% of the time. So, like, just moved to Singapore. Yeah, I mean, I'm thinking about it. Would I consider something like Vancouver? Why would I ever go to Vancouver? I don't understand that. Price for meth went down like 5x. I see. Is it maybe that safe drugs are illegal underground, so people try to create new ones to avoid that? I don't really think that's the problem because in San Francisco, there's an entire like 5 by 5 block neighborhood where everybody just does really nasty drugs out in the open and nobody cares and nothing is enforced there, right? Um, it's like it's like Skid Row on steroids and it's just like ugh, it's really gross. Like nobody's going to arrest a homeless person in San Francisco for doing drugs. In fact, last year San Francisco elected a district attorney who explicitly pledged not to prosecute quality of life crimes, otherwise victimless crimes like somebody doing meth in the street, but also crimes that have victims. So, like not prosecuting people breaking the window of your car and stealing your stuff out of it. Because, like, that guy must have a bad life if he's resorting to stealing. So, we shouldn't make his life worse by punishing the stealing or something, right? So, like, that's where San Francisco's at now. Which on the one hand is true. Like, yeah, if somebody's stealing stuff out of cars, you must not have a good life, right? Yes. But like, you're not, if you tell people that you're not going to stop that, then you get an acceleration of it. That's just what happens, right? So, like, at some point, just nobody's ever going to park cars in San Francisco because they'll all get broken into. It's going to be crazy. The thing I just said blows your mind. Yeah, I'm not sure if they arrest people for possession of large quantities of meth. They probably still would, I guess. But like, it's no, like it's well known that people just do drugs on the street in full view of police officers and everything. Like, that's just a thing. Putting all those people in prison for their addiction doesn't seem like the solution either. No, I don't think that that's the solution either. Um, but I mean, the problem is people are it's just too hippy dippy, right? Like the proposed solutions are all like hippie solutions and they don't really work without other things happening too, and nobody is willing to do those things. So I don't know. Every morning when you went to work, you would have a view of heroin users doing their thing. Yeah, exactly. think you come in at the wrong time. Let's get back to debugging. We were just giving time for the chocolate to get into my bloodstream and to help with the brain power. What I really need is like a neural link to like, you know, do the focus. Okay. Um, yeah, I mean, okay, so if I were to summarize the irony of San Francisco and other cities in the US, especially Democratic run cities, um, it's that they're trying to be kind and good to homeless people by not prosecuting certain classes of crime and by, you know, what having the various programs that they have, right, and structuring in the way that they do. But the irony is this just encourages the problems to get worse and sort of uh, pulls more people into that like homeless, dragging themselves across the street every day lifestyle. Um, and yeah, I don't want to get too much into it, but it's not like you can be trying to be compassionate, but if you're actually making people's lives worse and the whole situation worse and making things dangerous and scary and smelly and bad for everybody else at the same time, you're really not being compassionate to anybody, right? And so you need to observe that and say, oh, these things that I thought were compassionate are actually making everything worse for everybody. So let's change the policy and do something different. And nobody is doing that last part because nobody wants to admit that they're wrong, basically. Okay. So for some reason, when we convert this thing to an any, we are doing the wrong thing. And I suspect that would happen in bytecode builder. I thought there was something called emit cast to any. Um, okay. Emit writing any. So we could just like break in here and make sure it's on line 20. See what happens. Maybe we won't even get here, but I think we will. Okay, we're in the right file. All right, well, source type is an array, hopefully, right? Oh, it's a pointer. Oh, right, because it's that data pointer. Okay, this is really confusing. Really the problem, our L value register, okay, probably this is already wrong. This part This emit L value or copy of cast expression is probably the wrong part. That is the part that's probably doing the wrong thing. Let's see though. If that's wrong, we could actually reproduce it in other ways. Yeah, so that's the dot dereference. And the weird thing is it's a pseudo dereference thing. All right, let's do this. Okay, so we're emitting the L value. It's a binary operator. If it's a static array, it is the data pointer. This is actually not good, but maybe it's fine. Okay, this is bad. So we're going to end up here in this emit expression. And that assumes that we want an R value. So like, that's wrong. And it has nothing to do with what we've been doing. So like, why didn't this break before? I don't know. Maybe it was being masked by other things. Um, maybe our file wasn't loading this test for some reason. It's a little bit weird that this has to do with like, it was in pointer math, right? Like, it's weird that this has to involve code with relative pointers, and we were working on relative pointers. But this problem itself does not seem to have anything to do with relative pointers, but it just showed up. It's like, what? Maybe this like silently was crashing the compiler and our frickin' test program doesn't notice that. I bet that's what was going on. I bet the compiler was like asserting or something and we didn't notice. That's my theory. Can you vet the other code bases for times that they turn a U8 pointer into an any? I could, but it would just take time to do, and I would rather just make this work. Is remedy still not good enough? No, it's just that when I work on the compiler is already in Visual Studio, so I just use it to debug. I use remedy to debug other stuff. I use remedy to do things. I use remedy to do things. I don't want to go on Twitter. That's a waste of time. I was going to take a little, let's go distract ourselves. And then I'm like, nope, fight that reflex. Fight that reflex. Okay, so yeah, I feel like the brain power batteries are not at full. It's 6 p.m. already. It's like almost dinner time. That's why. It's like maybe it's that I've been eating chips instead of protein. Will there be some sort of public beta? Yes, there will be. I do not know exactly when it'll be. Okay. Um, yeah, I don't. So this is a very weird coincidence, but my theory is, yeah, that it was a crash that we weren't detecting, which means who knows, other tests could be failing in the same way. I don't frickin' know. All right. Um, so okay, so the basic fact is this emit struct dereference takes a value type that's like L value or copy, which means we need to return a pointer to this thing. And we're not doing that. We're returning an R value always, which is weird. Although I think, okay, like it's, okay, there's a little bit of confusion here. But yeah, we need to do this. I can see why I got confused and thought that this would be okay, but it's not. So this emit expression um, also doesn't have an argument that could be an L value, right? So let's just see, instead of calling emit expression, let's see if there's something else we can call. Takes an LR value type, right? Emit L value we could call, right? Like does emit L value actually do an R value if we give it? No. All right. So where were we? Here, line 2444. So we're just going to say if this is kind of stupid, but like at some point, I feel like it's been on my list for a while that there's just a little bit too much spaghetti involving L values and R values in the bytecode emitter and too many people calling other people for other things. It's a little weird. And I want to simplify it at some point. Okay. Um, we didn't fix anything. Why not? We're saying emit L value. We're going to have the same problem in here, probably. Oh, damn it. Okay. Yeah. So here's the thing. Arrays are considered big. There's like some confusion happening in this code. Arrays are considered big objects always. So if you pass an array to a function, it gets passed by reference always, for example. When you say emit an L value, that usually for big objects, we just assume that you want to do an assignment or something. So we return to you the address of the thing. But that's not right, because here we want the address of a thing, because we're doing this dot data of the array, which is just like a synonym for the array itself, essentially, right? In terms of the address. I'm rambling, but maybe a couple people know what I mean. So it's not good enough to do this because it's saying, oh, the left side here will be the array itself. And this says, oh, the L value of the array, that's just the address of the array, but that is not what we want. We actually need to make a thing on the stack. Okay. If we are being asked to give an L value for the data pointer, we actually need to return a pointer to the pointer, not just the address of the array. This happens when converting to any, for example. So we need to actually make some space on the stack and put the thinger there and stuff the value, so forth. I know I have something that sort of does this. Okay, that's version of relative string, emit cast. Here's where we make an any. I don't know, whatever. We need to do these things. So we're going to say plug or allocate, and then we're going to say return result register. Okay, here's what we do. Oh, no, we can't do that. No, 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 no. Take the placement out of there. And so we were doing this, linear allocate 8 on the stack. Oh, wait. No, this isn't right. So this plug or allocate is like, it's not what we want. Okay. We're just going to do this. We're going to do this linear allocation of 8 bytes. It really should be the pointer size, whatever. This is stupid, but putting it there. On the stack and the default alignment, great. So we have that allocation, and then we need to fill it in. So we're going to store the R value register through okay, we need to do this. So we make our allocation. This allocation is a data structure in the compiler. We need to get the address of that into a register. So we do that. We get a general bytecode pointer. We say that's the address of the ting-tangler. That's a stack allocation. We store a R value register through result register at pointer size again, which is stupid to use that, but whatever. And we return that. Okay, that might be the right thing. And we don't have bytecode. I think it's called current bytecode. All right. Well, that looks more reasonable to me. Now my touch ID is being rejected, so I can't read the chat. I probably missed some raids or whatever because I'm on my phone. Welcome anybody raiding for the past hours. If I missed you, I'm sure it was great. Okay. Well, let's go in our scroll back here to the pointer math. Okay, well, it still doesn't like that. But it's not broken the same way. This part works, but now the relative pointer part doesn't work. So we can go look at that and then reproduce that in our tiny program here and see why. Right. So b.data here is being assigned to buffer.data, but for some reason, this is a little bit complex. Let's do one step simpler than that. So here we've got all these things. We're going to say P is a pointer that's 16 of U8. P equals buffer.data, print P is whatever. All right. Little new line in there to make it easier. Okay, so P is a relative pointer pointing to this address, and buffer.data is also that address. Okay, so that looks fine. How about, well, let's do this string. This probably will fail because that's what failed in the other thing. Yeah. So for some reason, we're doing the right thing in one direction, but not the other one. What if I manually cast this, right? Does this solve the problem? Nope. Interesting. How about this? No, that's pretty weird. It feels like, it almost feels like assigning to relative string data pointers doesn't work, except that we did that in our other test program, our Hello Sailor, which maybe this also is a Hello Sailor. But anyway, we did that. Oh, except this is also still, it's like, how are we ending up with 0? That is pretty weird. That's pretty weird. And I rated silently, probably because chat is followers only. Oh no! Yeah, sorry, we had to do followers only chat because of all the stupid spammers. I don't know if I can fix that right now. Let's try taking it off followers only chat and we'll see. We'll see. Watch it immediately become total chaos like the state of California. I was wondering why chat was reasonably pleasant. Okay. So this is weird. This is weird. So what's the difference between this and our test here? Right? Because we did this thing. Oh, this was like a pointer to a string. And something about being a pointer to a string might have made it different in some way. Because here we do say s.data equals whatever, but it is a pointer. Oh yeah. Let's get credit for what we fixed first. Okay. So we're back here, and this is not working. So, I mean, I think we have, I think we can do like this or something. That valid directive. What is it called? Debug dump. It's called dump. Secret features. All right. Wow, that function's doing a lot. Holy cow. We really need to slim this down at some point. Look at how many instructions this is for this. Okay, this is really stupid. Lol. We're not going to worry about that for now, but that's really stupid. Okay. Wait, why do we think this has non-zero init data? I don't know. Okay. I think this is an array bounds check or something. Dude, I don't even know what I'm looking at right now. Okay. What is all this? Most of this actually, so calling print is going to be kind of nutty. Let's just, because that's involved. Just look at this. Wow, it's still a lot. We never made a little thing for this. Dude, what is all this? What am I looking at? What are we doing? Okay, let's do one thing at a time here. Empty. Empty function. Okay, great. That is what I expect for an empty function. Let's declare a string. Okay. So constant size 4, cleared memory, that is correct. And then we return, this is great. We get the address of the string on the stack and then we clear it. Okay. We make this buffer. How's that? Right? This is going to be the buffer. We clear, duplicate. Okay, this is freaking stupid, like I said, but it's still correct. It's just stupid. We should just clear constant size 100, but we don't do that for some reason. We could debug that at a later time. I just don't want to rat hole on it. Okay. This part. What the hell is this, dude? Holy cow. Okay. Um, okay, I kind of get it. It's a relative pointer encode and then a store. Let's actually do something simpler than this. What if we just make a local variable and assign it and it's like not relative? Okay, that's a lot less code. So like we're doing banana cakes amount of code for relative pointers is basically what's happening. Um, we probably shouldn't do that. I don't know why it's so much. We could go start looking at it, but and like a lot of these look unnecessary. Like we're doing number cat. I am not quite sure what's happening here. We can use these line numbers on the left to at least figure out where this is being generated. But like if you look, it's this sort of the same code happening twice, which is also a red flag. Or yeah, like this is pretty much the same as what's going on here with all the same numbers on the left. So it's like we're doing something kind of inefficient, probably. Okay, let's fix it. Let's one thing at a time. This is not correctly printing. This is just like, oh, there's this instruction and I don't know what the hell it's supposed to do. So let's go do that. So this is like, wait, why is it not? All right. So right after add to constant, we have this. And these are not in here. So that should be fine. So just this tiny victory. Tiny, tiniest thing. Okay, did I comment out now? Yeah. Okay, wait. So when we say X is assigned, X is just on the stack even. So we're just getting a register copy. Yeah, so that does basically nothing. Um, okay. Number flags are F? That's not right. That can't be right. So like, yeah, okay. So here's the deal. This used to store the flags in the B slot, but it doesn't anymore. So instead, well, we have a, we don't want to call it BC. So we're basically saying do this expensive thing where we convert the type to a string, leak it, we don't care about any of that. How do we do anything in here? Oh, we have the bytecode. Yeah. Type to string, oh, because it's interp arrow, because it is what it is. Okay, so now these number casts, we can actually tell what's happening. We want to get rid of this flags word too. So let's put them all right. Let's be assembly style %s and %s, right? And this is type name dest, type name source. Okay. Whoopsie, what? Oh, because I didn't put it in the right way. Now we get rid of R flags because that's stupid. Sometimes I can't program. All right. So now we can actually see it's like, okay, R7, which is the target, is a pointer to U8. R10 is the source, is an x64. Which is, by the way, a completely useless cast. I don't know why that's there. Instead of stack variable adder, we're just going to say stack add adder. Try to clean up the clutter a little bit. Okay. Stack address. Blah 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 blah. Okay. Yeah, this number flags is also useless for now. Anyway, so this cast is useless, but this one isn't, right? Sort of. Let's just look at this. So this like 1133, 1142, 1146, 1147, 2364, and then it changes, right? So let's look at that. So we are in the middle of emit conversion to full-size string. That doesn't sound good. We're doing that twice. We shouldn't be doing that at all. Because we should only be writing into this string. We shouldn't be trying to pull the string onto the stack. So that is something going haywire. And I'm inclined to fix that, even though it's not our actual problem. Although actually, this is our actual problem. The reason this is not being written to is because for some reason we're generating a temporary full-size string and then doing the assignment. And the reason we are doing that is because of our ensure pointer is full size situation is probably firing when we didn't want it to. Now everything connects. Now everything connects. Okay, this is good. This is good. We understand the universe now. So like if I take, okay, the print is gone, so basic can be gone. So we can literally just do this. All right, so it's called to full sized. You make conversion to full size string. We're going to break here. We're going to make sure okay, so site L0, site file name. Not file name, it is lame, but still. Okay, so we're in the right place. Line 48. Let's double check that. Yep, we're right here. So we are, for some reason, doing this. And why? Why do we think it is necessary to do that? Because we generated a cast. All right. This frickin' cast. To target type, implicit cast target type, blah, blah, blah. Okay. This is nutty. So let's, whoops. Let's find that. I'm about at the place where I want a break. So we might break the stream and come back later, but we found this problem, which is good. Okay. Um, right. Whoops, wait. What happened? I wanted this. That's what I wanted. Okay. So this tells us where that cast is being generated. It's from ensure pointer is not relative for some reason. Why? Infer types for binary. Dude, Visual Studio pisses me off so bad. It used to, like, way back in like 2002, it used to do this correctly, and then they rewrote it in frickin' C sharp, and now it doesn't. Like, which call to ensure pointer is not relative are we at? I guess it's this one. Like, we're really here, but it shows us here because it's like the last thing in the block. I can't inspect any of these variables, so I have to do this garbage because Visual Studio is asinine. Like they haven't fixed that in at this point almost 2 decades. It used to work great. Oh my God. All right. Um, yes, we were there. Can you not look at the call stack and click it to locate where it was called from? That's where I was. And it said here. Okay, that's what I'm saying is it gets the calling site incorrect. It goes, okay, basically, if it's the last statement in a block, it'll show the next statement instead of the one that still hasn't completed. And the problem is sometimes it's often like I could tell that I scrolled up and I was like, yeah, there's no other calls to this that are immediately before this, but there could be, like if you have some if statements with multiple clauses, there could be several calls to this that all fall out and come here. So it's a giant pain in the ass. Also, you can't like inspect the variables or anything because it thinks this stack is closed even though it's not. It's like it was totally written by the summer intern and they never fixed it. Like I don't. Why use VS over VS Code? Because VS Code is for punk Hacker News kid web developers. Like what? Like what? Why is that even a question? I mean, Visual Studio is bad, but VS Code is like play school Visual Studio. Like I don't even. I tried VS Code for a very short period of time, and then I had to get off it immediately. You know what VS Code is? It's like kind of trying to copy Apple, where Apple is like, yeah, there's no such thing as power users, so we're gonna rewrite our video editing program and just make it have there be three things that you could do. There's like three buttons of how to edit your video, and that's it, right? That's what Visual Studio Code is. You're so triggered right now. Well, if you like it, that's fine. I don't have to like it. That's an unforgivable bug in a debugger, easily reproducible and occurs often. There's all kinds of bugs in Visual Studio that are easily reproducible and occur often and haven't been fixed in like 10 years. All I've done is call it a bunch of names and not give any proper reason. Well, that's fine. Go ahead and use it if you want. That's fine. I don't care. I'm not, I have no investment in convincing you not to use Visual Studio Code if you're a Hacker News kid. That's fine. Um, all right. So we really shouldn't be here. This is not correct. So the question is, when is this necessary and when is it wrong? Okay. If this is an assignment, this is wrong, actually, because you can't assign if it's a copy. So yeah, we already have that. I'm not sure how that snuck through the cracks, but our test wasn't running, so we wouldn't have noticed. All right. It looks to me like we generated all the same garbage. Oh, wait. I mean, I did recompile, right? Well, we still have all the same garbage. I bet it still does the same thing when you run it. No, now it just totally crashed. Oh, no, because okay, never mind. We did this. I was like, oh, it's not working. It's working. Okay, it's still doing the same thing. Um, what I suspect is that there is more than one call to ensure pointer is not relative that's malfunctioning, right? This place isn't doing it, but some other place is like doing it probably. Or is an assignment isn't being set correctly, or I don't freaking know. We're in the same place. See how long it took that watch window to come up? All right. Binary, 46. Oops. So this is a dot dereference. Okay. What's going on here is there's a confusion. Okay. So I did just break this. I did just break this part. Okay. So the deal is our function is overzealous. We're going to have to audit this later, like after dinner, and come back and do it. So we have one function called ensure pointer is not relative. As in typer. And we call this, but the deal is it does more than we necessarily want, because in this case, it's like, oh, this is a relative string. So let's make a non-relative string on the stack, right? Which is not what we want to do on this case. What we wanted to do in this case was make sure that if this was a pointer, that it's not a relative pointer, but this isn't a pointer. This is a string that's a relative string. And so this function is doing more things than we want it to. So we sort of want to parse these things apart and say, okay, when are we just trying to make sure that it's not a bad pointer, right? And when do we want to convert the whole data type? And those should be two different things that we are more clear about. And yeah, I think after dinner we will do that. All right, everybody. Thank you for coming by. We're going to come back later on, probably. Um, yeah, I'm going to have some good Austin dinner. I can't believe it's 7 p.m. already. I don't know what happened to today. Days have been going by like this quite rapidly. It's pretty amazing. Um, but yeah, thanks for coming by. We will pick this up and attack this further in a bit. Actually, let's before we even do that, right? Let's just do this last thing of uh, whoops. Let's just verify because I want my subconscious to be able to work on this stuff. We're just going to verify that if we comment this out, that this particular demo works. The problem is our other test will now crash, right? Let's just do this though. Hey, look, it's way less spam code. And look, we actually get a non-zero data pointer. So that is what we want. We just need to sort this out, which shouldn't be that hard. The problem is there might be a lot of calls to this function and figuring out who really wants what, and we should document it well and all that. So I'll do that later. Thank you, people. Did I find a house in Texas yet? Haven't yet. I had second thoughts about getting one in the Dallas area. So I'm looking down in Austin. It's a lot more expensive down by Austin. So we'll see. Talk about it more later. Bye.